This is a 15 NDL 88. It's a mid-bass woofer designed for lightweight use for line arrays. I chose it because we make it in 3 different impedances. We make it in 4 ohm, 8 ohm, and 16 ohm. And these are the parts that make up a 15 NDL 88. There's the motor. This is the magnetic circuit that contains a permanent magnet on the inside and the magnetic gap where the voice coil sits, like this. The basket that the motor attaches to and holds the rest of the soft parts in place. And what we call the soft parts, the moving mass assembly. This is the part that does the work of the loudspeaker and moves and pushes the air. And that sits right in the center of it all like this. The reason I brought all these parts out is to show you the difference between a 4 ohm, 8 ohm, and 16 ohm woofer. And the difference is this voice coil. That's the only difference. We change to a 16 ohm or a 4 ohm coil, depending on which woofer you request, and everything else, every other part of the woofer, the magnetic assembly, the tinsel leads, the spider, the cone, they're all exactly the same. If the only difference is the voice coil between the 4, 8, and 16 ohm version of this woofer, then let's look at the voice coils. This is a 4 ohm coil, and this is a 16 ohm coil, and you can see the only difference is this one, the 4 ohm coil, has much thicker wire, and this one, the 16 ohm coil, uses pretty thin wire. Both have windings that are about 21, 22 millimeters long, but in that space, the 4 ohm coil fits about 32 windings, and the 16 ohm coil has about twice as many windings. It's got like 64 windings in the same space. And the reason is the thickness of the wire. This is about 0.46 millimeters, and this is about 0.28 millimeters. So it's much thinner wire. There's a lot more of it, wound many more times. So it's a higher resistance and therefore a higher impedance. When I say impedance, what I mean is this graph here. Because if you measure one of these coils with a DC ohm meter, a multimeter, you'll get around 3.9 ohms. But when you sweep this, because the system moves at every frequency, it has a different resistance, essentially. So when we say that it's an 8 ohm woofer, what we're doing is we're saying, okay, here's 10, 9, 8 ohms, drawing a line. And saying that's sort of the average. If you pick any specific point, it's not going to be exactly 8 ohms. But we don't listen to sine waves, and we don't listen to DC for sure. So what you're counting on is that the music you listen to is going to have content over the usable bandwidth of the woofer, let's say from here to here. And the average impedance in that bandwidth is going to be about 8 ohms. All 3 of these 15 NDL 88s, regardless of impedance, have the same power handling, 1400 watts. The difference is how many volts you need to put in to get the same 1400 watts into the coil, because you want to drive them to about their performance limit. And that's where we get back to riding my bike.
The test is done in free air, and that means it's not like inside your box. It's the best case for power. There's lots of cone motion to pump air around the coil, and it's the worst case for excursion because there's no box to limit excursion. So the power number is quite high, and the loudspeaker is taking a lot of abuse that may not be realistic compared to your real application. But here you go. It's very loud. Two, 4, 8, 100 hours. It's a long test, and we mostly use it for spec sheets.